Hello everyone. Welcome to 2021 IT Professionals Conference at UW-Madison. This session is Badger Analytics Modernization of Analytics Environment at UW-Madison. My name is Sanjana Aleti and I have been working as a BI Data Warehouse Specialist at Office of Data Management Analytics Services for 3 years. I'm talking to you today from my home office in Madison and walk you through Informatica Intelligent Cloud Services implementation in our journey to cloud.
Hello, my name is Randy Carey. I am a data warehouse developer. I've been with UW-Madison for about 7 years, and I've been with the Office of Data Management and Analytics Services since its inception.
This graphic presents a view of the current state of analytics at UW-Madison. In the center, you see our core ERP datasets, HRMS, SFS, and students siloed in their unique warehouse environments with separate logins, security, and business logic. On the outside, you see useful datasets that exist outside of the campus that analysts want to incorporate into their analysis. And just below the core datasets, you see the campus datasets such as Space, Canvas, and others that are not available in any warehouse. Because these warehouses are not co-located or intertwined at the data level, data analysts and engineers have created hundreds of duplicated data extracts and data sources where they have to merge and transform into the reports and dashboards. These practices increase overall costs for the university and potentially confuse end users who are presented with multiple versions of truth. In order to address these issues, the campus sponsors have agreed on a new strategy that covers 5 major areas. Today's focus will center on the infrastructure area, specifically the underlying architecture of Badger Analytics across 3 main tools. Snowflake, the storage and query engine behind our analytics; Informatica Integration Cloud Services, the data integration platform; and Tivoli, fully automated batch job scheduler that ensures that various jobs occur at right time and with right dependencies to build the data architecture with minimized idle time and improving the throughput significantly.
This is the 4-year timeline for moving from our on-prem databases to a modern cloud platform. In 9 months, starting in the summer of 2020, we stood up 2 Informatica secure agents on virtual Linux servers and instantiated our own ODMAS suborg. We rewrote 255 Informatica mappings. We created 8 databases, 425 tables, and 191 views on the Snowflake Cloud Data Platform. We configured 32 job streams with 237 jobs using the Tivoli scheduling software. With all those bits and pieces working smoothly together, our academic structure, Lumen, DARS, and finance data marts were productionized in March 2021. We were able to accomplish this in no small part because of the features, flexibility, and speed of our cloud-based ETL tools and databases. This is an overview of the Snowflake architecture. Snowflake is a cloud-based data platform providing database services scaled to your needs in real time. We interact with Snowflake's database management services through the top layers. Everything below those is managed by Snowflake. Disk space and CPU cycles are purchased from cloud-based server farms and presented to us as a coherent database platform. As a developer, I no longer need to worry about database maintenance or limited resources. When a user creates a database, it exists in name only. It is not until data is loaded Snowflake allocates disk space from its pool of disk farms. Only the amount of disk space needed is allocated. When data is deleted, disk space is deallocated and made available for other users. Virtual CPU cycles are allocated in Snowflake warehouses. These warehouses are sized by the number of credits used per hour. Smaller, slower warehouses cost less credits, whereas large warehouses process more data faster but will cost more per hour. You don't need to pay for 16 CPUs if you only need 2. On the other hand, if you do need 16 CPUs, it takes but a few clicks to ramp up the processing power. Since you are billed by the size of your warehouses, it is incumbent upon you to size them appropriately. In this paradigm, you are only charged for what you use. You never pay for idle CPUs or unused disk space. You are also not paying for hardware maintenance or software upgrades. This lowers the cost significantly, while at the same time eliminating any wait to provision database objects or to scale up your CPU power. And I do mean eliminate any wait. These changes in resource allocations happen faster than most commercial websites load.
Informatica Cloud is an integration platform as a service and an ETL tool. This is a cloud solution offered by the Informatica and contains some of the features of the Power Center. It is listed as one of the leaders in the Gartner Magic Quadrant. It has on-premise, on-cloud, and hybrid capabilities which are missing in many integration tools. It provides the capabilities of both batch processing and real-time processing. From layman's perspective, the Informatica Cloud's architecture is very simple. It has two main components, the Informatica Cloud and Secure Agent. Let's discuss on Informatica Cloud first. This is a bundle of hardware and software that Informatica provides us. We can utilize the resources of the cloud and run applications on it. Unlike the Power Center, there is no need to install on any client applications for our PCs. We can directly access the applications through the browser. Next, Secure Agent. This is a lightweight software that is installed on a server behind the organization's firewall in the on-premise. This provides connectivity between the cloud and the on-premise applications. The secure agent processes the data locally and securely. It also acts as a medium to transfer the data between the cloud and the on-premise. Informatica Cloud automatically updates the secure agent software and restarts it. The organizations can focus only on developing the applications and do not need to worry about the administration.
These are some of the highlights of Snowflake and IICS. Snowflake is considerably less expensive. The database management system is managed entirely by Snowflake. It is SQL compliant, so no new syntax to learn, and the point-to-point encryption ensures data security. IICS is a state-of-the-art integration platform as a service. There is no client software to install and maintain. Push-down optimization dramatically speeds up processing, and it has a very intuitive design interface. This is an overview of Badger Analytics data architecture. There are 4 components in play: the source systems, ETL processes, data storage, and user access. The source data comes from transactional ERP systems such as PeopleSoft and third-party software such as Lumen or Insight. The ETL processes schedule jobs that move the data, transforms, and restructures it for efficient retrieval. Snowflake is the cloud-based data platform where the data is physically stored. Tableau is the visualization software that presents the data as business insights. There are 2 parallel processing environments, test and prod. The test databases are where we develop our transformative processes and work with subject matter experts to make sure we have met their business requirements. Once the results are approved, the processes and data are moved to the production environment, thus making consistent, timely, and accurate information available to the broader user community. There are three general processing steps to transform transactional data into meaningful information. First, we copy all, or almost all, of the source system's data over to a database named raw. This data is copied on a daily basis mostly. Each day, the previous day's data is overwritten with the new day's data. This step copies the data very quickly with minimal impact on the source systems. This copy also provides us with a static snapshot that can be used as a starting point should the next steps need to be redone. The second step transforms the data by applying business rules. Some transformation processes require historical data and/or intermediate work tables. These tables are stored on the Silver database. The third step restructures the data into a dimensionally modeled data warehouse with conformed dimensions, facts, and aggregate tables. This data warehouse lives on the Gold database and is refreshed per predefined cycles, again on a mostly daily basis. Also on the Gold database are the data marts and data views used by Tableau users. There are data sets on the Silver database that will not be moved to the Gold database. This can be because the data does not lend itself to being merged into the conformed dimensions, or because the data owner needs it for a very specific purpose that does not require the time and effort to integrate it with the data warehouse. These data sets are frequently needed by a single department and are not intended for general consumption. The Bronze database is a place where data scientists, subject matter experts, and other data-curious explorers can work with subsets of institutional data, their own data, or their data merged with institutional data. They have complete control over this data and are responsible for its integrity and security. They can analyze it, manipulate it, and destroy it as they see fit. This discovery phase is an essential step in identifying valuable data and determining the best way to structure it into meaningful information. This slide describes the naming conventions for each of the databases. On the raw database, the data is organized by the source systems with schemas named SFS, HRS, etc. The Silver database is organized by domains, where DARS is an example. Work tables on the Silver database will continue to be organized by their source systems. The Gold database organizes the data into data marts generally aligned with domains. Student Data Mart is an example. The Bronze database will be organized by domains and subdomains as they apply. This shows the databases in quite a bit more detail. The arrows illustrate the data flow. Raw traditionally has been referred to as staging. Silver contains those one-off custom data sets. And the Gold represents the one truth, where the data is vetted and validated as official university information. This details the Bronze database. Data explorers can analyze data based on the one truth information from Badger Analytics. This way, all data explorers can start with the same vetted and validated data. Now we move on to Badger Analytics role-based access security. Access can be granted by security classifications, or domains, or subdomains. First, let's look at security classifications. These classifications are defined by our data governance policies and procedures. All domains have their data bucketed into one or more security classifications. Obviously, public data has wider availability than restricted data does. The important takeaway here is the hierarchical nature of these classifications. More restricted access also grants less restricted access in the same domain. Next, we look at domains and subdomains. In the slide, you see one or more steward areas, also known as subdomains, are grouped into domains. a subdomain can be in one and only one domain, whereas a domain can have one or more subdomains. If you are granted access at the domain level, you also have access to all the subdomains within that domain. So, if you have access to the enrollment management data domain, you have access to the data in the admissions, financial aid, and student record subdomains. On the other hand, if you are given access to a subdomain, you have access to that subdomain and only that subdomain. For example, if you had access to admissions data, you would not necessarily have access to financial aid data just because it's in the same domain. Now, let's put the domain-subdomain hierarchy together with the security classifications hierarchy. Here we put the security classification hierarchy in a matrix with the domain-subdomain hierarchy. In our enrollment management domain example, we see that it is divided into three security classifications: enrollment restricted, the red band; enrollment sensitive, the orange band; and enrollment internal, the yellow band. Public is not included to simplify the slide. If you are granted enrollment restricted access, this is at the domain level, you have access to restricted data in all the subdomains. And, due to the hierarchical rules of security classifications, you have access to the less restricted enrollment management subdomains, which in effect is all of them. Another example would be if you were granted access to the student restricted subdomain. You would have access to all of the student subdomains, but no access to any admissions or financial aid subdomains. In Snowflake, we have created a role for each combination of domain, subdomain, and classification. This provides us great flexibility to grant groups or individuals the appropriate access they need. This shows us the Snowflake database roles that are matched to the domain security classification combinations of the previous slides. A role is created for your NetID, and other roles are granted to your role. When other roles are granted to your role, you inherit their permissions. You can have as many roles granted to your role as you need to do your job. Getting access is pretty straightforward. A user requests access to a domain or subdomain. The data steward approves the request. The user is added to Active Directory and manifest group that has the appropriate role associated with it. Users who currently have access to employee or student data will be provisioned automatically when granted access to Snowflake. This process is more streamlined than the processes we've had in the past. Snowflake is accessible by web browsers or any database tool that supports ODBC connections, such as dbeaver or SQL Developer. You can sign on to Snowflake from anywhere on any modern browser. No special VPN, add-ons, or plugins are required. Snowflake provides each customer its own URL. UW-Madison has configured its Snowflake page to use our single sign-on dual-factor authentication. We will now begin a walkthrough of the web interface. Here you see the UW-Madison landing page used to access our instance of Snowflake. Upon successful authentication, our Snowflake web page comes up. This is where we interact with our databases and other database objects. Users of Toad, SQL Developer, or dbeaver will be familiar with the different sections. We have a list of databases, connection credentials, SQL Editor, and SQL results. In the top right of the page is your user account name and your default role. Selecting the drop-down arrow, highlighted here in green, will list 4 actions: change password, switch role, set preferences, and log out. Beneath that, it displays your organization's ID, name, Snowflake edition, the cloud data services you chose, and the location of the primary server farm. The switch role selected in the slide drops down a list of the roles you are authorized to use. Below the user information is the Snowflake Warehouse section. Here you will find the role that you are currently in, the warehouse you are using, and the database and schema where you are located. On the left, we see a database directory. It lists the database, schema, table, and view hierarchy. You can only see those objects to which you have access under your current role. When you select a table or view in the database directory, this section will display the details of that object. It tells you such things as the column names and their data types, the number of rows, and how large the table is. You can also preview data from here. This section is the SQL editor. This is where you write and execute your queries. This is where the results of SQL queries are displayed. The results are from either the editor or the preview data feature in the table details section.
IICS provides various applications or services that the customers can use for managing the application, developing jobs, and monitoring. The slide over here shows the various services provided by Informatica. Depending on the license, you might have some or all of the services available in your org. Today, let's discuss on data integration, administrator, monitor, and operational insights. When you select the data integration from the My Services page, the home page for data integration appears as shown in this slide. It consists of two sections, the home page and also the navigation bar. A home page contains overview, which lists the summary of projects, folders, connections, assets available in your org. Runtime environments. It lists the status of runtime environments that are available to you. And the My Jobs sections list the jobs that you ran in last 24 hours. Also, it has most recent project and the recent assets that were recently modified. Next is the navigation bar section. Here it consists of New, Home, Explore, Bundles, and My Jobs with import-export logs. This slide over here shows the various data integration tasks that are available to us in the data integration, which are mapping task, synchronization task, replication task, masking task, and power center task. In this slide, I'm going to introduce you to data integration tools. To satisfy any data integration business needs, IICS provides assets and projects. What are assets? In data integration, assets are nothing but mappings, task flows, and tasks such as mapping task, synchronization task, and replication task. Assets also include components such as business services, maplets, and hierarchical schemas. We can also use assets in multiple projects. All assets must be part of at least one project. If you create an asset without specifying a project, the asset is created in the default section. Projects. All assets are organized in projects. We can create multiple folders within project to contain the asset that we need for a project. The types of assets that we use in a project depends on the services that we use. For example, on a data integration project, it can include assets such as mappings, tasks, and task flows. As you can see here in the slide, we have organized our project in data integration for handling the course and program data and named the folder or a project as ODMAS Lumen, and within this is a subfolder called Lumen Data Integration Layer that lists out all the mappings and the task flows. Now that we have understanding about data integration tools and tasks, let me show you an example of a mapping, how it looks like in IICS. Or here, it contains of 4 different sections. On the left side, it is a palette which lists all the various transformations which are similarly available in Power Center or also in the IICS. On the middle part, there is a mapping canvas and it lists just the mapping, how the data and explains how the data flows from source to target. At the bottom, once you highlight each individual transformation, it lists the properties such as connection, what kind of target it is, what are the fields that are used in the target, and also in any field mapping. And at the rightmost corner, we have a toolbar which has the delete, zoom in, zoom out, and rearranging. In this slide, I'm going to talk about other modules that IICS provide. Let's start with Monitor. We use Monitor to keep track of jobs, imports and exports available in the org. When you select Monitor from the My Services page, the navigation bar provides options for monitor activity as shown in the slide. The navigation bar on the left has options like Running Jobs, which provides runtime details about the data integration jobs that are running or have completed within the last 5 minutes. All Jobs. It provides the details about all data integration jobs in an org. Data Ingestion provides details about the mass ingestion jobs in the org, if any. Import-export logs. It details about imports and exports that are running and have completed. File transfer logs. It provides the details on the file transfers in the org. Source control logs. It provides log of actions on source control objects in the org. To view the details about a specific job, import instance or export instance, click the instance name. Let's talk about Administrator in this slide. Administrative tasks for IICS are performed in the Administrator service. When you select the Administrator from the My Services page, the navigation bar provides options for IICS administration, as shown here. Based on our license, we can add new users, configure user groups and roles for individual users, create user groups, assign users to the user groups, create and manage connections, and also create and manage schedules for the tasks. Now let's talk about another service provided by IICS called Operational Insights. It gives us visibility into the performance and operational efficiency of the Informatica infrastructure. Runtime statistics and asset configuration metadata is uploaded from assets to the service on configurable schedules, providing an accurate, up-to-date overview of the Informatica deployments. We can hover over a bar in any chart of the Overview tab to view the summary details. Information about the job is current and as the most recent data refresh. Data is refreshed approximately every hour at the top of the hour. From this slide, we can instantly give more attention to the 9 failed jobs. The Operational Insights Overview tab contains few frequently used panels. The top target panel displays a summary of data, rows read and written by the 5 most used connections in an org. The top projects panel displays a summary of jobs run for the top 5 projects in an org. To view the top folders panel, we need to select folders from the drop-down menu. You can choose to view the data for the past 24 hours or for the past 7 days. Data volume panel displays a weekly summary of rows processed every hour. You can view data for 1 week, actual, 2-week average, 1 month average time periods. We can hover over the chart to view job information for a day and time. Similar to Power Center workflows, we use a task flow to control the execution sequence of a mapping task based on the output of the previous task. For example, you want to run 2 mapping tasks in a sequence. However, you do not want to run the second mapping task as soon as the first task ends if you get a warning on the first mapping task. Instead, you want to run the second mapping task to run after 2 hours. You can create a task flow to orchestrate this scenario. When we create a new task flow, we have predefined templates like parallel tasks, sequential tasks, etc. Once we select the template, the steps are already presented on the canvas and we need not to add them separately. You can invoke and run a task flow from the task flow designer or on a schedule. Using the new asset dialog box as shown in the previous slide, let me explain how this parallel task flow was created. Our major requirement was to run 2 or more data integration tasks in parallel and then make a decision based on the outcome of any task. We started with a task flow that contains a start step and a parallel step, decision step, and an end step. You can add other steps at any point on the canvas. This task flow is currently scheduled to run daily weekdays at 2 a.m. and an alert is notified to the users when the task flow is completed successfully. While we have designed task flows in IICS for covering the individual projects, but we do have a requirement to execute various projects with dependencies. We use Tivoli IBM Workload Scheduler to meet those needs. Tivoli dynamically balances workloads and manage high volumes of activities across multiple systems and applications. It manages process deadlines, workflows, and decision making to react to ever-changing conditions before they impact our business needs. Tivoli Workload Scheduler is a fully automated batch job scheduling system that improves job throughput and greatly reduces operations costs. TWS also helps us plan and organize every phase of batch job execution. During a processing day, TWS production control systems manage the production environment and automate most operator activities. It prepares our jobs for execution, resolves interdependencies, and launches tracks at each job. Because our jobs begin as soon as the dependencies are satisfied, idle time is minimized and throughput improves significantly. Jobs never run out of sequence, and if a job fails, TWS handles the recovery process with little or no operator intervention. In this slide, let's understand the components of Tivoli with an example of how our team has created and function. A job is an executable file, task, or a command and its attributes. It is scheduled to run as part of a job stream. When we add a job to the job stream, we can define its dependencies and its time restrictions, such as the estimated start time and deadline. A job stream is a list of jobs that execute as a unit, along with times, priority, and other dependencies. It determines the exact order of the job of execution. Time constraints can be specified for both jobs and job streams. We can specify the time that execution will begin and the time after which execution will not be attempted. By specifying both, we can define a window within which our job or a job stream will execute. For jobs, we can also specify a repetition rate. For example, we can have TWS launch the same job every 30 minutes between the hours 8:30 p.m. and 1:30 a.m. TWS has its own queuing system with different priority levels. Dependencies are prerequisites that must be satisfied before the execution of a job or a job stream. They can be specified for both jobs and job streams to ensure the correct order of execution. And that brings us to the end. Randy and I sincerely appreciate that we have had this opportunity to narrate about Badger Analytics' journey. We would like to thank you for your time and attention today. Thank you for joining us. There are few different ways you can get in touch with us to have your questions answered. We will be hosting a live Q&A from 1 to 1:30 p.m. this Friday, June 4th. You can also feel free to reach out to our team at any time at info@data.vis.edu. Thank you.